Hello and welcome to the new video, installing a Snort IDS. In the previous video, we had set up centralized logging. In this video, first we will install the Snort daemon package, then enter the network interface which you want to monitor, and finally enter the network range which you consider local. To start monitoring our network for irregular traffic, we are going to start by installing a Snort IDS. Snort is one of the oldest and most feature-packed open source network intrusion detection systems, IDS. It is free for use, and there is a wide collection of rules freely available for it, as well as information and support on designing your own custom checks. So after this brief introduction, we will now see how to do it. Install the Snort daemon package using sudo apt-get install snort. When prompted, enter the network interface which you want to monitor. For our example, we will use ETH0, which on our router is the LAN port. Next, enter the network range which you consider local. We will use 192.168.0.0/24, which is previously defined as the LAN range. You can specify multiple CIDR blocks by having them comma separated without any white space. Cool. Now let's see how it works. The network range that you defined as local earlier are used to populate the home_net setting within Snort. Home_net and external_net are used within Snort rules to allow you to specify the direction of the flow of packets, which you care about. Snort also wants to know what network interface it should put in promiscuous mode and listen on. Which interface you want to use has some rather interesting implications as to what you can see and how it will look. Now we will see some important terms. First one is WAN interface. Your first instinct may be to monitor your WAN interface since it is externally facing. This is also very useful as it will allow you to detect attacks against any public-facing services that you placed on the router box itself, rather than forwarding to an internal server. This approach will work, but it has some limitations. The main limitations is that even though monitoring from the WAN interface will show you any malicious traffic between a remote server and a computer behind your router, the traffic will always show the connection as being between the remote server and your router. This is because Snort is monitoring the external interface. It is seeing the packets before they are rewritten by the kernel. Another limitation of monitoring via the WAN interface is that your log will be very noisy. Any system connected to the internet is under a constant barrage of malicious traffic from bots. There are systems out there infected with known viruses, worms, and rootkits that may attempt to spread themselves automatically via automated SSH scans, or attempts to exploit old vulnerabilities in software that you may or may not be running. Next is LAN interface. Monitoring the LAN interface allows you to see the internal IP address associated with a malicious request, but will miss any packets destined to the router itself from the internet. It will, however, allow you to detect certain additional types of host-to-host communication on the internal network, such as ARP, DHCP, and other forms of broadcast traffic. Last one is dedicated interface. One limitation to using either the WAN or the LAN ports is that you will only detect traffic that passes through the router in some manner. If a machine on your network is compromised and is attacking the internet, either approach will detect the traffic. However, if a compromised system on your network is attacking other client systems on the network, the traffic will go unnoticed as long as they do not attack the router IP. So, how do we see client-to-client traffic? Long ago, this was trivial on smaller networks, as the systems were often connected via hubs, which essentially turned all network traffic into broadcast traffic. Since the change to switch networks, the traffic became more isolated, generally, but it does make our case here more complicated. The best solution to this problem is port mirroring, which is a feature that is available in some better managed switches. Port mirroring, also called Switch Port Analyzer, SPAN, on Cisco gear, allows you to send a copy of all traffic on a given network port, or VLAN, to a specific network port. This allows you to plug a dedicated network interface on your system running Snort into it, and then receive all the network traffic you want to see. Another good point for using a dedicated network interface on your Snort box for monitoring is that it allows you to configure the network interface to be brought up without being configured with an IP address. By not providing an IP address on the monitoring port, you prevent people from addressing the device directly. Nice! In this video, we installed a Snort IDS. In our next video, we will learn managing your Snort rules.